Have you ever wondered why Jupiter, the largest planet in our solar system, has the most extreme storms? It's a fascinating question, isn't it? Now, let's embark on a journey to this colossal planet, a realm of raging tempests and swirling clouds, a planet of storms. Jupiter, the fifth planet from the Sun, is a hulking gas giant, the likes of which dwarf our home planet Earth. This enormous celestial body is primarily composed of hydrogen and helium, similar to the Sun. But don't let its gaseous nature fool you. Jupiter's atmosphere is a turbulent cauldron of activity, teeming with storms that can last for centuries. Now, when we talk about storms on Jupiter, one can't help but mention the Great Red Spot. It's a tempest so large, so enduring, that it has been raging for at least 300 years. Imagine this, a storm larger than our entire planet, swirling and churning for centuries. An earthly hurricane looks like a mere squall in comparison. But the Great Red Spot isn't the only storm on Jupiter. Oh no, this gas giant is peppered with storms, each one a mesmerizing whirl of color and tumultuous winds. These smaller storms, often white or brown, are no less fierce than their red sibling. They whip around the planet, adding to Jupiter's vibrant and chaotic atmosphere. These storms, both the Great Red Spot and its smaller counterparts, are a testament to Jupiter's dynamic and volatile nature. They're a reminder of the sheer power and scale that our solar system can manifest. So why does Jupiter, a planet over 11 times the diameter of Earth, have such ferocious and long-lasting storms? What's the secret behind its tempestuous nature? What elements conspire to create such a turbulent and storm-ridden atmosphere? Well, dear listener, there's a myriad of factors at play. From its rapid rotation to the heat emanating from its core, each plays a crucial role in making Jupiter the stormy behemoth it is. So what makes Jupiter the reigning king of storms in our solar system? Stay with us as we delve into the heart of this celestial storm king. To understand Jupiter's extreme weather, we first need to understand what Jupiter is made of. Dive into the heart of Jupiter, and you'll find it's not like Earth. In fact, it's not like any of the rocky planets we're familiar with. Jupiter is a gas giant, composed primarily of hydrogen and helium. These are the very same elements that make up our Sun, and they dominate Jupiter's composition. Now, you might be wondering, but where's the ground? Well, Jupiter doesn't really have a solid surface like Earth. Instead, it's a swirling mass of gases and clouds stretching thousands of miles deep. The transition from outer atmosphere to the deeper layers is gradual, with no clear boundary to say, here's where the surface begins. This lack of a solid surface has a dramatic effect on Jupiter's weather. On Earth, our weather patterns are influenced by the ground below us. Mountains can block winds, oceans can absorb heat, and the rotation of our solid planet helps to stir the atmospheric pot. But on Jupiter, there's nothing to block or absorb, nothing solid to spin and mix the gases. Instead, the weather is driven by the motion of the gases themselves, creating a perpetual ballet of swirling storms and jet streams. What's more, Jupiter's enormous size means there's plenty of space for these weather patterns to play out. Its girth is more than 11 times that of Earth, and it's over 1,300 times our planet's volume. Just imagine the size of the weather systems that could form in such a vast space. But it's not just size that matters. Jupiter's rapid rotation, it spins on its axis once every 10 hours, also plays a part in its weather, but that's a topic for another time. So when you look at Jupiter, you're not seeing a solid planet with weather patterns dictated by its surface. Instead, you're seeing a massive sphere of gas where the weather is driven by the movement of the gases themselves. Jupiter's unique composition sets the stage for some truly out-of-this-world weather. Another key player in Jupiter's weather drama is its astonishingly fast rotation. Now I know what you're thinking. Rotation? What's that got to do with weather? Well, I'm glad you asked. You see, a day on Jupiter, that is the time it takes for the planet to complete one full rotation, lasts only about 9.9 Earth hours. Yes, you heard that right. If you lived on Jupiter, your day would be over before you've even had lunch. This rapid rotation is the fastest of any planet in our solar system, and it leads to a fascinating phenomenon known as the Coriolis effect. This effect is a result of the rotation of the planet. and it has a significant impact on the movement of the atmosphere and the weather patterns we see. On Earth, the Coriolis effect is responsible for the rotation of weather systems like cyclones. But on Jupiter, with its intense rotation, the effect is much stronger. This strong Coriolis effect causes the gas in Jupiter's atmosphere to be pulled into separate bands that we can see when we look at the planet. These bands are the stripes you see on Jupiter, and they're full of storms. So, the fast rotation of Jupiter causes its atmosphere to be whipped into these stormy bands, but it's not just any old storm. These are the most extreme storms in the solar system. They're so strong and so powerful that they can last for hundreds of years, like the famous Great Red Spot. So, it's not an understatement to say that Jupiter's rotation really stirs things up, but it's not just stirring up the gas in its atmosphere. It's also stirring up a whole load of questions for scientists who are trying to understand just how this gas giant works. Jupiter's rapid spin doesn't just make its days fly by, it whips its atmosphere into a frenzy. But there's another secret to Jupiter's stormy nature, hidden deep within the planet. You see, Jupiter is not just a passive recipient of the sun's warmth. Rather, it's an active generator of heat. This colossal planet emits nearly twice as much heat as it receives from the sun. Now you might wonder, how can a planet generate so much heat from within? The answer lies in the intriguing process of gravitational contraction. Jupiter, being the largest planet in our solar system, has an enormous gravitational pull. This immense gravity squeezes the planet and makes it contract, a little bit like squeezing a rubber ball in your hand. This contraction generates heat, which then radiates out from the planet's core and into its atmosphere. But this isn't just any heat. It's the heart of a planetary furnace, the driving force behind Jupiter's stormy and unpredictable weather. This internal heat fuels convection currents, which are essentially rising and falling streams of gas. These currents work a bit like the bubbling water in a boiling pot. The heated gas rises towards the exterior, cools down, and then sinks back towards the center. And this constant churning of gas stirs up the atmosphere, leading to the formation of powerful storms. Imagine a pot of soup on a stove. The heat from the burner warms the soup at the bottom of the pot, causing it to rise to the top. As the soup at the top cools, it sinks back down, creating a circular motion. This is very much what happens in Jupiter's atmosphere. The heat from within the planet stirs up the gases, creating a turbulent, stormy atmosphere. However, Jupiter's internal heat is not just a source of warmth. It's a storm maker. It's the engine that drives the ferocious winds and colossal storms that we see on the planet's surface. It's the reason why Jupiter, more than any other planet in our solar system, is a world of extreme weather. This internal furnace keeps Jupiter's atmosphere churning and its storms raging. Among all of Jupiter's storms, one stands out, the Great Red Spot. This tempest is nothing short of a celestial enigma, a storm that has been raging for at least 400 years, and possibly much longer. Yes, you heard right, 400 years. This is a hurricane that's outlasted generations, centuries, and even entire civilizations here on Earth. Now, to give you an idea of the enormity of this storm, the Great Red Spot is about 1.3 times the size of Earth. Picture this. You could fit our entire planet into this storm and still have room to spare. It's a hurricane that dwarfs all others, a storm system that truly earns the title Great. The winds within the Great Red Spot are ferocious, reaching speeds of up to 430 kilometers per hour. That's nearly 3 times faster than the strongest hurricane winds recorded on Earth. The sheer power and longevity of this storm are hard to comprehend, but they offer us a glimpse into the extreme conditions that reign on the gas giant. So why has this storm lasted so long? Theories abound, but the most accepted one is that the storm feeds off Jupiter's internal heat. This heat rises and cools, creating a cycle that fuels the storm and keeps it going. It's a self-sustaining tempest, a vortex of energy that shows no signs of slowing down. However, recent observations have suggested that the Great Red Spot is slowly shrinking. The storm is becoming more circular and less elongated. Yet, despite these changes, It remains the most powerful storm in our solar system and continues to captivate scientists and space enthusiasts alike. Jupiter's Great Red Spot is a testament to the planet's extreme weather, a storm system unlike anything we see on Earth. It's a reminder of the sheer power and mystery of our universe, a phenomenon that continues to challenge our understanding of planetary weather systems.